In this video, we want to analyze a Zener voltage regulator circuit. The first step is to determine if the Zener is operating in the Zener range. To determine that, we first remove the Zener and replace it with an open circuit and determine the Thevenin's equivalent voltage across the Zener. In the second circuit, we can see that the voltage across the open circuit is the same as the voltage across R sub L, which would be the Thevenin's equivalent voltage. So VTH is equal to V source times RL divided by R1 plus RL. This is equal to 15 volts times 300 ohms divided by 150 ohms plus 300 ohms. Substituting these values into a calculator gives us VTH is equal to 10 volts. So VTH is greater than V sub Z, thus the Zener is in regulation. So we can proceed with the analysis. So now we'll go to our next circuit and we replace the Zener with its equivalent model, which in this case would be a 5.1 volt supply. We now can analyze the circuit. The first thing we need to do is determine the load current. So step number 2, I sub L is equal to V sub Z divided by R sub L, since these two are in parallel. This is equal to 5.1 volts divided by 300 ohms, giving us an I sub L of 17 milliamps. Now the next step is to determine the current through R1. The voltage across R1 is the difference between the voltage on this side, which would be 15 volts, and the voltage on this side, which would be the Zener voltage of 5.1 volts. So expressing this, IR1 is equal to VS minus VZ divided by R1, which is equal to 15 volts minus 5.1 volts divided by 150 ohms. This yields a current IR1 of 66 milliamps. So now we know the current through the load, and we also know the current through IR1. We can now find the Zener current. Using Kirchhoff's current law, sub Z is equal to I sub R1 minus I sub L. This is equal to 66 milliamps minus 17 milliamps which yields a Zener current of 49 milliamps. This concludes the analysis of the Zener voltage regulation circuit.